screen. Yeah, everyone's ready to start, or you want a couple of minutes?
Okay, hello everyone. My name is Jitendra Khasdev, and I work for Azure Technology in a storage domain. So today I'm going to look into the HTTP file system basics. So what we are going to do, I'm going to give an overview of IO stack, how the storage IO stack works. Then after I'm going to describe how to HTTP file system overview and whatnot in that. Then after I will go into the disk layout, how basically HTTP file system looks on the disk. Then after I will talk about the super block and inode and data blocks which care for us. And then after finally the preferences. Okay. So basic layered architecture of Linux IO stack is this. The number of n processors running. There is a common virtual file system. It's a common interface. For every file system, whatever the file system is that the process doesn't know, right? Everything is taken care of by the virtual file system. So virtual file system is a kind of a router which decides where the IO is going to be. So it decides it's going to be ext2, ext3, ext4, whatever, what not. So it's basically a router. Then after those IOs are the buffered IO, it goes into the first to the buffer, and then after it create a request, and it consumed by the device driver. So here is a broader view of Linux IO stack. So here on the top of you can see the number of processors like read, write, open, stat, and cmod are running. They are connected to the VFS. VFS take care of where needs to be routed. So there are a bunch of block-based file system kind ext2, ext3, ext4, ZFS. There are other file systems as well as like network file system, pseudo file system like RAPFS and stickable file system. And there are also a special purpose kind of like RAMFS. If you don't want to use a block device, then you can use RAMFS. So once this layer is passed, the IOs becomes the block IO. So the middle layer is known as a block IO layer. For the file system, the input is a VFS and output is block layer. So for the block layer, the input is a file system. So whatever the IO we are doing on the system, it will convert into the VIO, and VIO will consume by the block layer. And here is the IO scheduler works. So the VIO basically works whatever the IO, whatever the request you have generated, it creates a queue, and based on the queue, it selects which is the driver and which needs to be consumed. So underlying the hardware like SCSI drivers and the SATA and ATA, other what IO drivers works, and the physical drivers, it also works. So anybody heard about filter driver? No? Continuous backup recovery. So this is my kind of domain where I work basically. So we work on continuous replication of data and filter driver. So here we hooked on basically in the middle of the RAPFS. Sorry, I'm mistaken. From middle of the block layer and the file system. So there is a file system also called RAPFS, which sits on between the BFS and the RAPFS. We create a hook on the block layer and the file system layer to create to catch the IO and modify them based on things. Okay, so now the ext42 file system. So it is created by Remy Card and other people. So basically, Minix ext2 file system was firstly developed, not ext2. It's a ext file system was developed in the Minix. So Linux thought that this file system works well, so it should work into the Linux. So the Linux kernel community started working on Linux ext2 file system, and it's most widely used in Linux community. For now, I don't know how many people use the ext2 file system, but yeah, it was one of the most popular file systems.
But the core design is the same on ext3 and ext4.
Yeah, exactly. But there are lots of features coming into the base file system on ext3. Okay. So here is a does anybody have format your disk? If you have used Windows, then you have a user format NTFS, right? If you have a Linux, then you have a user MKFS. When you does a MKFS .ext2 or -f file, -t file system type, it will create on the block disk this similar kind of stuff. So here's the disk layout structure. So whole disk is divided into the blocks. First 1024 byte is reserved for the boot block. If the disk is a boot block, then it would be written. Otherwise, it will be leave blank. So every block contains a super block, group descriptor, block bitmap, inode or inode table, and data blocks. We will look into the source as well, how these are laid on the system. So in the super block, as you have heard about it, so super block is a kind of housekeeping of the house actually, housekeeper of the house. Sorry. So super block have all the information, not all the, most of the information of the file system. How many blocks are the free? How many blocks are laid with that? What are the bitmap, data blocks, and inode tables? All the stuff information is there. And group descriptor also. Group descriptor basically represent every group of the block. Bitmap of block. So what are the blocks are the freed from the data blocks? It will maintain in the block bitmap. And inode bitmap, what are the inode table entries are freed? It will be maintained in the inode bitmap. And the data blocks contains the data. So here you can see that every block in every block there are two entries are very repeatedly, a super block and group descriptor. So super block and group descriptor only read it from the blocks block group 0. It just used for the consistency. If something is crashed, then it could recover automatically by comparing all the checksum of other super blocks. So it for the only consistency. Okay. So super block. Super block is basically a metadata about the file system, maintain every block group of file system. I already talked about it. Usually being read from the block 0. So magic number. Yeah. So if you do MKFS, so -t, ext2, ext3, ext4, every file system has own magic number. So when MKFS run, it checks if you have passes ext2, ext3, it checks first magic numbers, and if it matches, then it formatted that particular file system. And the mount count, how many? So basically, how many ext2 file system were mounted? Maximum mount count is possible, and block size, free block, and first inode. Basically, we required a first inode to keep track of other inodes as well. Okay. So in system, let me go to the source. So if you see, there are a couple of files in the C. There are buffer.c, cadf, the most read and write for the list. So when you does read, right? When you call a read system call, so I don't know how it passes from literacy to here, but control comes to here, and then after
Control shift plus.
Is it okay? Is it visible? Yeah. So VFS read comes to here and it calls a wrapper function. It is a wrapper function. It calls function to here. Yeah. So here is a file pointer which we call the read function. Whatever the read we will define in our file system, I will go into the ext file system where the read function will define. So we does a read system call. Its control come to VFS read. Then after it calls to VFS read, and this file pointer will take care of which file system need to be called, because this file pointer have a information which file system pointer need to be called. So based on this pointer, we can call the very specific read to the file system. Okay, so I'll talking about. So this is the VFS layer which we have talked. Then after we have to go into the very specific file system. So we have a bunch of ext2, ext3. ext3 is deprecated from the okay, ext. So here is a ext2.h. Okay, so here is a one more concept I would like to introduce. There are two kind of data structure in file system domain. In-memory data structure and disk data structure. So in-memory data structure, if you will go into the source, you will find the two super blocks information, which one represent the in-memory data structure, and similarly if you will just below down here, it goes out. So this is a disk data structure which is written on the disk basically, and the info which we have seen. So this is an in-memory data structure. What is the difference between those? This data structure is read from the disk and read it from that particular in-memory data structure. Basically, both can be used common, but I don't know why those are separated. But most of the entries are the same. Okay, so here you can see. Okay, so what I talked about, the super blocks maintain all the data like the inode count, blob count, result count, all these entries here. This is how the super blocks looks like. Also, it should point to the first inode from there. First non-reserved inode. I think this would be possible. Okay, the magic number which I had talked about, the magic signature. Every file system has a reserved magic number for identification of those. So this is how the basically super block is. So we talked about, yeah. So here is inode. So again, in the Linux, everything is a file. Like your symlink, your network file, your device drivers, everything is file, and every file is represented by the inode. So inode is basically, if you say in the file system, if you told me the what is the file, then I will tell in the file system this inode will represent the file. So basically the main thing of the inode is it keeps the pointers of the data blocks. if you have a inode of a file, then you can reach to the data blocks of that particular file. So again, it's a basic building block of ext file system. Every file is represented by inode, and again, it's contain the metadata of file. Superblocks contain the metadata about the file system, and it contains the metadata about the file. Again, I could show you the same data structure in the source as well. Yeah. So, which has shown here is similar kind of stuff. Okay. So the main thing is that data is 15. So it has a 15 data pointers of the file system. So I'll discuss about it later when I will discuss on the thing. I should switch back. Yeah. So the 15 pointer which I am talking about. The inode contains the 13 direct block. 13 direct block. If you look at this picture, you can define what is the minimum size of file and what could be the maximum size of the file in the Linux system. So the direct block could directly point to, or the block size is defined by the user at the start. By default, it is right now is 4096. So in the direct block, if you have a pointer data 0 to 30, you can directly access the pointer, and there is an indirection level of pointer. Means the indirect block contains the pointer of 4096 block of pointer, and there was in that pointer you will find the data. In triple indirection, this will contain the pointers, and again those blocks will also contain the pointer, and final pointers will redirect to your data. So this is how the data is laid on the inode. So yeah, here is a pointer of indirection. Here you can look at more about the data blocks. So 1 to 15 there are data blocks. 1 to 13 you can directly access it, and from the 13 onwards you have a single level of indirection, and from the 15 you have a triple level of indirection. This is how you can reach the data blocks. Yeah, these are the references. I have created a small, very basic toy file system. Maybe I can show you that one also.
What are the features of your file system?
It's just mount the file system and you can just read it, right? Just a basic file system to understand the basic concept. Sudesh, I don't have internet.
So I take back what I said earlier about ext2.
Here's the Wi-Fi.
Yeah.
Can you see that?
I can see that. Just a minute. No, I didn't get it.
So the access point is called reserved. I mean, you see it.
No, I can't see the access point actually.
Yes. All of my face. And then they have trouble.
Just turn off wireless and then turn it on again. Network manager. Turn off wireless and turn it on.
So now we wait here. The one that we gave over here.
Is this 5 gigahertz?
Yes.
Oh yeah. Do you support 5 gigahertz?
I don't know.
But then I have both cards.
You have both?
Yes. The one
Yeah.
No, last time I have used it, right? Last time I have used it.
So
Yeah.
I think I have changed the configuration to prefer a 5. So for everyone on 5. 5 is my. But then
Maybe
it
his
should.
card has
So somebody can give me a Wi-Fi for a minute.
Yeah. I can do that. So now if I
your question?
So I take back what I said earlier about no one using ext2. There is a very useful use for ext2 on embedded systems. The reason being that ext3 and ext4 have journaling capabilities, which cause a lot of flash wear.
Okay.
So if you have a small amount of flash on your embedded system, it's preferable to use ext2 as your file system.
Yeah,
So
but
you're not constantly writing to the flash and causing
yeah, but ext2 has a problem. If it is crashed, then it is not easily to be recoverable because it does not have a journaling capability.
Yes, but then in most embedded systems, what you do is you make the entire file system read-only.
Okay.
So corruption is not an issue.
Okay.
This is about devices that are going to be in the field for 10 years or more. You want to avoid writing to the flash as much as possible, and it's a read-only flash. And then you can have overlay FS or something else for all the write bits.
Can you please complete this last one?
So ext2 does not have journaling capabilities, which means that it's not constantly writing to your flash. So on embedded systems where you're using a small amount of flash or maybe even a USB stick, right? You only have a certain amount of writes on your flash, 100,000 writes or something. So you want to avoid, minimize writing to the flash drive as much as possible.
Because of this journalist.
No. In general, for let's say this device is going to be in the field for 10 years, right? 100,000 writes, that's a finite amount of writes. When you're using journaling or anything like that, it's constantly writing to the flash, which means you're wearing it out. And flash has technology called wear leveling. It tries to spread out the writes across the flash so not one point doesn't get completely burnt out. So ext2, because it does not have journaling, it's helpful. What he says is right, recovery it causes lots of corruption because there is no journaling. But in those devices, you make it read-only. So it's a read-only thing that you read into memory.
There's no harm of just losing.
Yeah, so even if you yank power and put it back, it's fine. It just comes out. And if you really need to write something, you either use tempfs or overlay FS to.
Anyway, if it's a read thing, we don't need.
Yeah. So I was showing you. So I named it as a moonfs. So I have already taken a reference from somebody has written. I will also give this. There is one called sample.fs. So I have taken the reference from that particular file system as well. But this file system I have written by myself in the code, but I have taken reference for it.
Can you increase the font size?
Again, yeah, that would be fine.
No.
Is it okay?
More.
Okay. So just have a look first. So I have created a MKFS first, just a very simple MKFS if you can read it very quickly. So what it does, it first create a make boot, which I said that 1024 byte is just leave blank. Then after it make a super block, and then it create a block bitmap, inode bitmap, and then calculate inode and make the inode table, and then calculate block and the make bitmap. So it just write it first. Basically, if you have a loopback device, or you can just allocate some memory to the RAM and just malloc it, and then after it will lay down this structure. The structure is very simple. If you will go through, I am not sure whether I have written it somewhere.
So your on disk format is identical to ext2 or?
Yeah, not ext2. It's just very simple.
Oh, you made a very simple.
Yeah, just one super block, bitmap, inode table, and rest of the inode block. That's it.
There's no version number.
No.
So you don't plan to.
Yeah, so I just keep it. So it's very simple, like super block bitmap, which I have already shown to you, and the other thing I could show you is the dump fs. So it just reads superblock from the system. And yeah, so the superblock which I described into the source of the Linux kernel, because I need that particular header to read that particular block from the system. So I included that one, and I'm just reading this superblock into this superblocks structure and printing out the whole stuff. What are the superblocks memories? So it's just very simple. And other than that, okay, I would like to just, so in Linux kernel, every file system is just a kernel model. It's just simple as this. So if you have written a simple kernel hello world module, that would be enough to understand to this particular file system. So yeah.
So I think except ESP2, right? ESP2 is or used to it. What for initial code, you would have ESP2 as the file system built into the kernel.
Yeah.
And then you have the
I don't think that's that's only because it can be a kernel module indeed. Because
So-
I would not want to use EXE kernel.
So your root partition has to be somewhere, right?
yeah.
So the root partition, it could be x32, x33, button or something else, and you can also build your own file system as a kernel module, and you can load it and you can just format that disk using the mkfs, and you can use that particular file system.
So what happens during initial boot? So you have the initial boot.
So
which will read
Grub
boot partition.
already has support to read EXE2 and other files.
Grub initially gives the
Grub can read that super block, find the files, find the kernel, and then do it.
I guess Grub loads the kernel modules for the file system.
Grub actually can read the
Kernel is
kernel.
not
Grub
there.
first needs to find the kernel.
Okay, but
Z image.
see, suppose we want to mount MKFS partition or something else during the boot. So we
But that
can
will have to happen after
During the boot, that's part of ETCFS tab.
We have seen this. And for that you need to actually insert those use those kernel modules in the Grub.
Not in Grub, it's in Unitard. It's in the Unitard. It's not part of Grub. So the way most distros go to, I'm sure Fedora as well, boot is if you go to Grub configuration, if you go /boot grub.cfg, you will see lines basically saying that the initRD line. And your initram affairs, you basically say that this is your V image, and you might want to pass in module parameters. Those module
Basically,
parameters.
first it loads the
First it is the kernel. That loads the initRD.
plus the
That
modules which you can
and the modules that it
Suppose
needs.
I have a Grub installed. I have two operating systems currently on my disk. I want to mount an ISO to be loaded by the Grub. Okay. So you can boot from an ISO using Grub, right?
You can go to an ISO disk, you mean?
Yes.
Okay.
So for
I
that,
don't think it's Grub. That's syslinux, right?
I don't-
You're talking about like bootable USB and.
So I don't know what it does in the backend, but you can load an ISO, means boot from an ISO using Grub.
Yeah, so okay, he's actually brought it up.
Okay.
So if you go down to so you're talking about these insmods here, right?
Yes.
So this isn't being passed to Grub.
So
Because,
Hold on, this
when
is
does
the
IO
IO.
works?
So because your OS is not loaded into the memory, right? Prior to that, if it is inserting a module, so where is it insert?
Could you go back to
Just
So at what point does that smart get called? I mean, that's
Because OS is not loaded.
that probably answers my question. We're talking about ISO or this one? In this case,
No, ISO is different. I mean, ISOs use syslinux too, not Grub.
Yeah, so you
what I
have-
need that module for is to mount that partition, not to
Yeah,
load
okay,
that.
so look at the init ID line at the bottom, right? Where the cursor is. That's the init ID that's passed to the kernel.
Right.
The kernel is already booted up at that point.
Because when
Yeah,
you
the
are
only
You
group
cannot have init ID without a kernel.
I think you need the.
Maybe I don't understand.
No, because your OS is not loaded. Your grub is just running, right? So at that time, you need some modules to mount the partitions. You can mount the partitions.
Okay. So what you're saying is these are the modules for grub, not for the kernel. That's what I'm saying. These are not for the kernel. This is not Linux. This is grub modules. Even grub has been made modular to add support for various file systems.
So insmod ext2 is essentially you can grub to add ext2 support.
Yeah.
To read SDA.
That is what I am almost 99% certain of, because this seems to have changed at some
Grub has support for Linux.
This seems to have changed a lot since.
So you're saying it has, so you're saying it has direct support for Linux modules.
Why it needs for Linux module for, let's suppose, some part of file system or something it wants to just do initial setup and some memory which it should understand, it needs that support, not the
Not
Linux
just for
kernel.
file systems. Actually, I have seen that.
So the idea of being able to just use the Linux modules is that you're not replicating.
Yeah, so that is just about importing the code, right?
Right.
Yeah.
Or as he's saying that it is directly talking to the KO files.
Because it will not
Directly
understand,
using the
it
KO
will
file.
not understand because
It's all
it
ABI,
will
right?
have the-
Yeah, if you have the right API, it
infrastructure.
should be.
Code is a lot of the cases similar or maybe same thing, but it will not be actually kernel modules.
No, it could be. That's what he's trying to say.
He's saying that they probably added support so that it directly uses the Linux kernel modules, direct KO files. But that means that you would have to import other parts of Linux, not only to understand the module formats, but also the whole insmod process.
Suppose if you want something to do, you want to process something before the operating system goes. So you
That's
should be able to-
whenever we first
That is your bootloader.
grab this for us,
Yes.
then
In the
this
bootloader.
init RD or init RamFS, it also has some of the drivers and all these things.
So now what basically ends up happening over here, if I understand correctly, is that grub is doing all the file system reading from boot. Is that? And,
Okay.
and then it loads everything for the kernel.
GNU.org grub manual insmod insert the dynamic grub module called module. It's a grub module. It's not a-
So then
They might have reused the source code from Linux.
Okay,
It's a grub module.
for we have compared it for.
So my question still remains then how does the kernel read the file system, the boot file system before the initial runs?
That's where you typically compile in support for
whatever the boot.
not necessarily. Okay, no. You still don't need to compile in exe console. What you can do is you see the line Linux, 2 lines above your cursor. Linux, that's your kernel, right? So your kernel, it says where your rootfs is and other options. Your kernel is just one file, so grub automatically jumps into your kernel. Your kernel
That's fine.
finishes booting to a point and then
That's fine.
says, I don't have everything needed to boot because I can't find my root file system. I need a init RD. So then
I'm not
it
talking
loads
about
the
the boot
init
file
RD.
system. I'm talking about the boot file system. Does the kernel never need to write
No,
read boot?
grub is basically
So grub
loading.
now does everything.
It's like almost a kexec into the kernel. Grub is calling the kernel, and the kernel goes halfway through and says, I could boot here, but I can't find my root file system. I need to load init RD, and from init RD I'll find all my other modules required to do all kinds of things, LDM, root file system, all sorts of
Then init RD has the modules.
It has all the modules compiled for that API of the kernel, so it's specific to which kernel.
I think it was some years ago that you needed only ext2 inside the kernel and everything else could be done as a module. I mean that seems to have that requires
So I would like to have so it is not necessary to only specific to HT2. You have to be only one file system if you
the
boot
boot partition, basically whatever is a boot partition file system type, that type had to be compiled into the kernel.
Yeah,
And anything else could be module. This was probably 7-8 years.
Grub already reads the file system, so you don't need.
Now it does, yeah. Now it does. But then we're talking 7-8 years ago when it was Grub 1.
Okay, possible.
Yeah. So that is now necessary.
Okay.
Maybe next.
In a sense, Grub itself has become an operating system. It reads file system.
Change
also.
Is there another operating system for the system?
Now UEFI is the same. UEFI can read all sorts of things.
Okay.
Okay.
We would need
So can we back on the file system? Okay. So
finding
basically init module basically call an exec module call. So if you compile this file system, you will got this particular module, and whatever the function which you wanted to call from the init process, you have to write here, like allocating the cache or memories and all the stuff, which will be done here. And then after, you have to register the file system with a specific moon type struct. So this is a type of if you can see here, I named it as a moon. Again, you can go into the source and you can find what is the definition of the struct file system. So here is the file system type which I have assigned to the value, the char value, the entry. This is an object. Kill super block, which the file system will be out. Then this function will be called, and there has to be one more function. Yes, this mount function. When the file system is mounted, this function is getting called. So we have assigned the two function pointer, moonfs mount and moonfs kill. So you can find the definition of this particular functions. So it has a API mount bdev block device to mount a block device. You have to call this particular function, and to fill the super block, you have to pass the pointer of a function. So the moonfs fill you will find above. So just below. So what I told that when the file system is getting mounted, right? So you did the MKFS. The file system is already laid down. All the data structure has been created, like my MKFS. So in that particular function, when you does the mount /sd asdp to particular mouse pointer, what it does in the RAM, it read the in-memory data structure. It allocate an in-memory data structure, read the disk memory data structure, and assign the value to it. So here you can see that I am reading the log data of this data and assigning to the in-memory data structure, and allocate an inode, and then after just return it. So once this function is getting called successfully, our file system is getting properly mounted. There are other stuff. I am sure there has to be. Yeah. So Moongate inode basically I will tell you. I already tell. There is one inode automatically created when you mount the file system. This inode has associated some property called file inode operations and mool FOP operations. So if you will go back this file operation, yeah, this is the super operation which the super blocks can perform. We can just ignore it for now. File operations. Yeah. So for the inode. So yes, whenever the file is created, right? Sorry, this is the mkdir file system. Okay, this is the directory operation. Whenever the directory, when you perform any operation on the directory, this set of functions has been called, and whenever you perform the operation in the file, this setup function will call. I haven't defined much operation on it, so you can see that.
You only implemented one of those.
Yeah. So these again, these are the structure. These functions also. If you look into the moon MK node, where the moon is written, then which was written by me, and else is I have used by from the kernel itself. The kernel APIs also provide this one. So yeah, this is the how the Quickscape works. Anything else which I need to show you? Right.c. Yeah, these are the address space which we used for when the mapping is done. That's it. That's it from my side. If you like to hack in this particular file system, you can just clone it, import it, and try to compile and install it. Thank you.
Just one note I have is in your presentation, could you please tell the first slide architecture thing? You said your company works in some of the.
Yeah.
Okay. I couldn't understand it.
Yeah. So if you can look into that, there are two things, right? The VFS block layer and the device drivers. These are the area of device drivers. So we generally hooked on two places. First place is and second place is this. So when we try to hook on VFS between the file system, we use the RFFS and we create the hooks on it and we catch the reads and write IOs to continuous data replications. So basically it used for I don't know, CDP or CDC, something kind of
Where
stuff.
you replicate?
So the model
Is it RAM or?
not actually RAM. So it used on the big data centers. So it apply on whatever the data is coming onto this. We hook this particular
redundancy.
Yeah, it's a backup.
So you're just putting hooks to back up the data.
Yeah, exactly. So not exactly we are copying old data. We are I don't know complete algorithm inside that, but it captured the whole big map. What are the big block has been changed. If big block is changed, then we only record that particular blocks, and else we kept it.
So they have a folder?
Not exactly. We are service based, so we provide service to the company. So other than the VMware has a snapshotting, right? So somewhat incremental data, you can say backup recovery.
Okay, you also do incremental.
No, my product is working on the iSCSI protocol layers.
So it's a level.
Yeah.
That answers my.
That's it. Anything else?
So your all this is being sent over iSCSI transport then?
Yeah, exactly.
All the replication is being sent over iSCSI. So it's basically in a rack in a data center. You have transparent backups.
This is not related to the code or
Which one?
so I have had this that as a partition it's super block has been corrupted. I don't know what happened. So basically file system is corrupted. I have a backup of super blocks and everything. I don't know how to figure out which one is the correct super block and how to restore it. So if there is a tool or something to
They are-
restore the right position.
So if you know what file system is mounted on that hard disk, then it is little easy. So every
It's
file.
ext4 Ubuntu machine.
Okay. So every file system has a recovery tool. So I think FSCA there's some kind
There's
of.
an alternative super block as well, right? both
So
of them
only
are
the
trusted?
super block is your problem, then that is not a problem.
Okay,
If
so
your
how-
data is corrupted, then problem. Then there's no.
I don't think that data is corrupted because I'm unable to access the files.
So I have shown you that.
How to restore the super
So see, there are number of blocks, right? So if you're so there are lots of checksum is created. So it again the number of checksum is the same and number of checks is unsame. Most of the checksum is sum, then it will be replicated with the unsame. It is simple as this.
So what I'm asking is there a tool that I can
So it is FSCS.
Test this.
test this?
Super test.
Okay.
Just look at the command line tool and early work is a recovery.
test this.
And the default options for ext4 for FSCK, I believe they create 2 copies of the superblock.
Right.
So if one of them is corrupted, you might still be able to mount your file system using the other one, but you might have to specify specific command lines to use the alternate superblock. I think that's the default options for fsck.ext.
What do I have to code that?
No, not during booting. You will have to boot off of a USB disk
Okay.
and then look at the raw hard drive and then figure out where that other superblock is and then give mount options to mount the phone.
So
Don't touch your hard drive. Don't try to boot off of that. It will just cause more problems.
So I must not closely follow to ext4, but I closely follow to butterfs. So butterfs is a whole set of utilities for that. I know the exact name for the particular utility. But the superblock is corrupted in butterfs. The beauty of butterf is that it automatically gets corrected. You don't need to use any tool.
Okay.
So it has a B tree structures and there are metadata and checksum trees are maintained. There is a kernel thread repeatedly working on that, and it observe the checksum is consistent or not. If it finds that there is something inconsistent, it automatically corrected on the fly.
But you're basically saying it doesn't need to run FSCK.
Yeah.
But that doesn't solve this problem, which is that it's already corrupted.
Corrupted. Yeah.
It could be from external entity magnet being swiped from the hard drive that corrupted that. So in that case, not even butterfs will help.
Yeah. Yeah. That's it. Any question? Yeah. Thank you.
Okay, so I just need to figure out what to do the next meetup. Depends on what it is.
I would love to know what sort of audience are you because there are always new
So there's, yeah.
Is it college students? Is it professionals? Is it a good mix?
There will be like a round of interaction with them.
That would be takes to know.
We have an hour.
We have 10 give like 1 minute for everyone.
It is more than
30 seconds for everyone.
Probably start
Sorry.
Let's do a round of introductions so that we know each other. This is only a third meetup, so just wanted to.
My name is Kiran Padwa. I'm staying in Karadi and I'm working for NVIDIA from last 1 year.
What do you work?
So mostly I'm working in kernel areas. So like Linux drivers. So NVIDIA has its own driver for their devices.
You work on Tegra?
GPUs. So I'm working for GPUs.
Do you work on Tegra 2.3 or something?
No, not Tegra. Tegra is a complete chipset including the GPUs. I'm completely working on GPUs. Okay. So it's have their own device driver for the GPU, graphics processor device. So I'm working for that.
Hi, my name is Gaurav. This is my second meetup. I work for a company called Veritas. It's into storage domain. So this is very relevant for it's funny that every meetup there's a different person coming from Veritas.
Last time you were there.
I was the only one.
And
Was there someone else?
hopefully you'll come for next meetup.
It's very good. So I might have shaved.
You outsource the training.
It's been a month.
Okay, so hi, my name is Karim. I was working with Ola for 3.5 years. Now I do freelance consulting in DevOps. So I was working as a DevOps. I do DevOps. I also do some training and work on that. Yeah, I attend meetups.
Hi, my name is Amit and this is my second meetup. have kernel panics and all this research. So I just did that to learn more.
Nice. So we should probably do a session about networking.
Routing protocols. Do you do routing protocols?
Not more of routing protocols, but I can give an overview of basic networking.
So do you have your own stack, or do you use something like DBW or AWS?
Opened up your
OpenWL.
Okay, hi, I'm Durga. I'm working in Vodafone primarily, and I'm working on a very different technology. I'm working with SharePoint, so I am looking for an opportunity to switch my domain and get into development. So I'm taking these meetups as a platform to learn more about things that I'm working on.
I am Rishika. I am in career computer science. Co-instead of computer science. I'm looking for small operating system related projects and learning more about it.
My name is Shivani. I'm also a third year student from PICT. I've been attending 580s Pune Linux. This is my first meetup.
My name is Shweta. I'm also college student. I'm pursuing BTech in IT from Stanford College. I'm working as an intern in building system. Actually, I'm working in database domain, but I have completed my 2 certification in that. So I have a very curiosity in open source as I have attended the I have project I'm looking at region in Bentley. I'm in last year BTech. And also I completed 2 certifications, ICSA and ISC, working on thread networking, that is the build Raspberry Pi as a router. And also I'm conducting workshop on IoT as well as open source. In open source I'm taking very basic for diploma colleges. I think it is the best platform to me improve my knowledge as well as my communication and all these things. I'm using my second year. First one is Raspberry Pi. Like this is the second.
My name is Girish. I'm working with the slightly solution provider. We provide embedded solutions to clients.
I'm Pankaj. I work with Red Hat, software developer. Work with mostly virtualization and kernel related things. Interested in memory, networking, and many different things. So I'm joining this meetup from very first meetup, and I'm also taking active part in organizing over here. So overall, I want to share my knowledge, and I want to learn also from people with the sessions and whatever, any good discussions, anything which I can learn to get out of it. That's it.
I'm Shweta from I'm working in EMC software as a security analyst. So we learn more about the operating systems for performing the memory depth analysis.
What area of security? Is it kernel or is it product level security?
Not product level, but perform the malware investigations and systems. For basically for the business continuity. Basically, more operations.
So it's not about finding zero-day exploits. It's more like malware.
That's probably aspiration. To be able to find 0 days. It is very good.
Hashtag right good. Hashtag right good.
Hello everyone, my name is Bhargav Surya. I am currently pursuing my final engineering communications from JSW Institute. I feel that only having a theoretical knowledge is not enough for a fresher student. So I started meeting up to different experienced candidates from meetup app. And my domain area, I would like to work on an IoT thing. I have chosen some different models to work on. So I take an experienced candidate and help from them. What are the areas? Because simply having a theory knowledge is not enough.
something practical knowledge will give you a hike in your knowledge and give you a little bit strength to do something else.
So you're developing IoT.
Now I'm having a little bit of grace in IoT, done small works on Raspberry Pi, and for final engineering I'm switched to, not I have taken an IoT, but I merged the two parts of the IoT and data mining. Data mining.
I'm Nikhil. I was in Shenzhen, China for 7 years. I moved to India and back in Shenzhen I led a community of startups. So we started from a 50 people community as small as this, much smaller than this. And I was leading it when it was a 2,000 people community. And we went to a point where the government chose me as one of those few foreigners who succeeded so well in Shenzhen. So I was a face for their Make with Shenzhen campaign. So on a hardware architecture level, I know a lot, and I also know on the practical side of how to make a product at very good price. I mean, there are a lot of good guys in India doing a lot of stuff, but probably there's a lack because we don't have the environment and we don't have the ecosystem for hardware. So we don't know what are the right components to choose and how should we go to the market. So now that I've moved here, I really see a huge opportunity and I want to change things. I'm much of a dreamer. I go places and I actually change things. So I really think that we will change things here. I believe that in 1 year down the line, you would see me somewhere different, and I want to lead the IoT community here, and I want to make a lot of changes here. So I would like to have support from everyone, whoever wants to, and however I can give back to anyone. But we would want India to succeed. That's a big dream that I don't see. When I see in Shenzhen, I see that every week there is a company making so many new products, and if you ever have a chance to even read about Shenzhen, I think longer, but design like people like this, they all sit in a place called as Manshan where design happens. The GDP per capita there today is $49,000. That includes even you put $49,000 to the head of a sweeper. And people don't know that how do you make so much money doing things, and that is knowledge that I have, and I want to tell people that there is a way to participate together and make money. You cannot make it individually. It is an ecosystem play. That each person is specialist on a certain domain. They all co-work. They work. Each one shares that money. You make a large profit out of something, and then it gets divided. Here I see there is expertise that is like on multiple, but no one is like one working on, because we don't really work together. Each company is trying to do the whole piece. So that's different. So there are certain things that we want to bring to India, and then that's why I'm leading a community. So we'll ask people to join us and then share a lot of knowledge. And we're also putting money for it. I mean, whatever money it takes to do this, it's not that. And that's the whole idea. I'll talk to a lot of you guys separately and ask you.
Hi, my name is Amit Kucheria. I work on everything from a mainframe to desktop Linux for Canonical, phones for Nokia. Currently working with Lenovo on 96 boards effort, and on IoT as well as mobile and enterprise platforms for ARM.
My name is Suresh. I lead a combined function team in Kernel, and I also maintain the UC hub. And I also help maintain the space, it's an makerspace that we set up 3 to 4 months ago. So we also
Hi everyone, my name is Puneet. I work for a startup called AppOrbit, which is into creating a platform for maintainers for the enterprise industry. I work there as a DevOps engineer. I've been a DevOps engineer for the past 5 years. I mostly work with a startup, so I'm quite curious into the technology, so I'm definitely interested.
Okay, so I guess most of us are working somewhere at home, and there are some students. There's here and there as well. But then
Students are good because they can bring their friends around the campus.
But I guess in terms of kernel focus, there's still not a lot of people who are currently involved in that, including me, right? So that's something that we probably build out hopefully.
Very mixed crowd. I mean, is there other things people would like to know about or be willing to do your own research and present to us? Because not all of us are experts in every area. I mean, security, I heard security and networking. I mean, those are things which we talked about at the last one as well. That if there's some